Welcome to Study Loop.
In this question, we are going to calculate the capacitance of an RC circuit and the time to reach a certain voltage across the resistor in this circuit. So to find the capacitance, we're going to use the fact that the time constant, tau, is equal to the product of the resistance and the capacitance. So our capacitance is going to be our time constant divided by the resistance, and our time constant is 18.0 times 10 to the negative 6 seconds. And our resistance is 15 kilo ohms, so 15 times 10 to the third ohms. And that gets me 1.29 times 10 to the minus 9 farads. So you might say 1.2 nanofarads. And now we don't have a specific equation for RC circuits to calculate the time to get a certain voltage across a resistor, but we do have a way to calculate the voltage across the capacitor. So the EMF of the battery is going to be equal to, at any point, the voltage across the capacitor plus the voltage across the resistor. And so the time for the resistor to have a voltage of 16 volts, let me make that a little bit clearer, 16 volts equals the time for the capacitor to reach 8 volts. So we can find that. And our equation for the voltage across the capacitor is the EMF of the battery times the quantity, 1 minus e to the negative t over tau, or you might see it as RC. So let's substitute what we know. So we need 8.0 equals 24.0 times the quantity 1 minus e to the negative t over 18 times 10 to the minus 6. So that gives me 1/3 equals 1 minus e to the negative t over 18 times 10 to the minus 6. And we can now rearrange this to be, I'm going to put the e on the left side just so that t will be on the left side when I'm done. So my e term equals 2/3. All I did was add e to both sides, subtract 1/3 from both sides, and now we're going to be able to take the natural log of both sides. And I get negative t divided by 18 times 10 to the minus 6 equals the natural log of 2/3, which is negative 0 point. And I'm going to keep a bunch of extra decimals until I'm done. 405465 108, where the 108 is a repeating decimal. And the reason I do this is so I can get a lot of accuracy in my final answer. So now if I multiply that decimal on the right side by 18 times 10 to the minus 6, well, times negative 18 times 10 to the minus 6, I am going to get 7.3 times 10 to the minus 6 seconds.